Okay, so we have some sodium here. Okay, it's one of the alkali metals. And it's stored, let's see if we can get this so you can see, it's stored in a liquid, it's stored in oil to keep oxygen from getting to it. And even though it's stored in oil to keep oxygen from getting to it, you can see the how white it looks. Can you see how white it looks in there? Okay, we'll get it out here. I might have to get a different kind of tweezers here. Small bottle. No, I'll get it out. Okay, that's a white coating. All right. So metals have a luster. Okay, a luster means that they are shiny, but this one doesn't look shiny. The reason it doesn't look shiny is that it has an oxidized coating. Has an oxidized coating. So this is what you're seeing right there is not the metal itself, but the oxidized coating. Oxidized coating just means it has oxygen. Okay. If we cut it open, you can see the shiny metal. Okay, you see the shiny metal part now? All right. It's a very soft metal. I should have left that thing over here to put it back inside because I only want to use a small amount here for this demonstration. Put that back in the jar. And it's highly reactive. Remember when we were doing metals, we said that when we were doing periodic properties, and in Unit 2, we repeated it again in the last unit, that the first column of metals are very reactive. You remember that pattern? No? Get out your Unit 2 test packet, please, your text in Unit 2. Turn to page 107. Turn to page 107. Look at the periodic table that shows the pattern of reactivity. Okay, where are the highest areas of reactivity when you rank elements in the periodic table? Sodium and potassium are the highest over there. That whole first column there is a kind of ridge. It's a high point of reactivity. Okay, but along that ridge there's a peak, and that peak on that ridge is where sodium and potassium are located. Okay, on the other side of the periodic table, what's another area of high reactivity? Chlorine. Okay, those are important things to remember. You need to remember the things you learn in Unit 2. You need to remember the things you learned in Unit 1 and Unit 2 and 3 to do Unit 4. Okay, these things keep coming back again. All right, so if we take this sodium and we simply react it with water, we're just going to put it in water. I can't get it to let go. So it's stuck kind of to the tweezers. There we go. Reacts quite violently. And that's just a tiny little piece of it. That's sodium. Just sodium metal. If we put larger pieces in there, you get popping, and well, I could turn on the lights. I guess you could have seen it'll give off light. Okay, you might have seen it a little bit there. It actually glows. What's burning is actually hydrogen gas. The sodium reacts with water, rips the oxygen off of the water, leaves the hydrogen, and the electricity that's produced is causing the hydrogen to burn. So it's actually a two-step reaction. Okay? Everybody write down what they saw. Got observations written down on what happens when you put sodium, pure sodium metal in water. And pouring that out in the drain with lots of water. And I'm getting some more water. And let's take a look at what happens when we react another metal. This time potassium. Drop my hands here. What's the symbol for potassium? K. Okay. You need to write down that we're working with potassium now, okay? We're going to do the same thing. And let's get a small piece of potassium. I can get it out. Okay. And you can see that coating is sort of grayish, not so white like the last one. We'll cut it open and see what the inside looks like again. But that's an oxidized coating, so it's oxygen combined with potassium. See how soft it is? And you see the inside there is shiny. Shiny on the inside. And it's already beginning to oxidize a little bit. If you look carefully, you can begin to see it starting to turn a little gray already. That's how fast it reacts with oxygen in the air, even with the oil that's coating the outside. Alright, let's see what happens when we put this in water. Even more violent, huh? Okay. The last one I have to work with here is lithium. Lithium. There's some lithium. And we're going to cut this a little bit just to see this. You can kind of see where it's shiny there. Okay, hold on one second. Just sit down and we'll get you to take care of that in a minute, okay? In a minute I'm going to have you put that in, log in and put it in your file and stuff, okay? Alright, so here's lithium. And you can see how shiny it is inside. It's a little bit harder. It's not quite as soft as the others. Alright, we're going to get a little piece off over here. And that's the gray oxidized coating on the outside we talked about. And one more time. Let's see what happens. Once again, we're getting that reaction with the water, violent reaction. Okay? And that's just the metal. Just the metal, nothing but metal that's reacting there. If you look closely, you can see how it's glowing a little bit. Okay? It doesn't have quite as violent a reaction as the potassium did. Okay? Alright, so that's just a chance for you to see one kind of reaction that can occur between, you wouldn't think that metals would react with water that way. I mean, metals are used to it. Iron doesn't, copper doesn't. The kind of metals you're commonly working with, that you have around your house, so if you're wearing jewelry, okay? Obviously, your jewelry is made of a metal, and it's not going to react with water like that, okay? But some metals are much more reactive than others. Although iron will oxidize and form rust, copper oxidizes and forms that sort of greenish color you see on copper sometimes. Okay, so let's talk about the kind of